My friends, welcome to the weekend special series. This weekend, I will be working on Model Mania 2023. This is a model developed by SolidWorks, and this is part of their challenge. One model comes out each year and then do some challenging among the CAD users. So it's a live event. I'm not in part of that event right now. I'm just practicing. So the challenge is we will have to build this model in phase 1, and then the phase 2 will come out, and then we'll have to make a transition from phase 1 to phase 2. So it's the phase 2 is not a new object, it's modified phase 1. And this time this is a PDF. It's not a technical drawing like we used in the previous Model Mania models. With that, let's go ahead and start work on FreeCAD. I will be using 0.21.2 current stable version to build this model. So first of all, my work approach is to build this middle one first, and then two of the limbs. And then I look at phase 2. I see this right part, this nut holder, where the nut and bolt will go in, remains unchanged. This center part remains unchanged, and this arm kind of swings upward with an angle of 45, which is angle 90 if we compare that to that 45. And also this length changes. And one other thing is like this hole is a slotted on the phase 2, which is actually a circle on the phase 1. So these are the three major changes. Everything else remains same. So with keeping all these three changes, I will try to make it a parametric configuration table, and so one click switch between phase 1 and phase 2. So let's go ahead and start work in part workbench, and the middle part is a tube. So I'll go ahead and draw the tube real quick with outside diameter of 50 and inside diameter of 42. And the height is given on the technical drawing as 30. So you can download this technical drawing from SolidWorks. So search on the Google with keywords Model Mania 25 years of Model Mania, and it will show up. Okay, so we have the center part done, pretty easy. On this one though, now if I look at the axis cross, it is sitting at the bottom. Now I want to make this symmetric by this axis, the horizontal axis. So I want to have this axis cross in the middle of this object. So that one way to do it is actually come to the position and say on the Z, I want to make it a formula. So height is what this height of the object is. I want to divide it by 2 and make a minus, so it moves down just a little bit, so it's at the midpoint. Now don't need the axis cross. Now we are done with this part. Let's go ahead and work on the nut holder on this right side, and that is going to be a sketch on XZ plane, or I can do it from XY plane, but XZ plane will give me more benefit. So XZ will go there, and it will be a simple rectangle. Notice how I put this line inside. So actually let me hide this for a moment. So this height is going to be 25, and then I'll have to delete this line, draw an arc to replace that. So, and then let's go ahead and make these two tangent. Okay, so we have this, and this radius is already there. It would be 12.5. This point, at this point there is a circular through hole. So that one is radius 3.3. Got that. And this point is 42.5. Okay, so this point is 42.5 from the center. So what I want to do is I want to make these two horizontal distance of 42.5 minus the radius, as I said, 12.5. So that's our distance. Now on this one, where it goes is part of a discussion that I want to have with you. So I want to bring this tube visible, and this one by the technical drawing should end right there, right at the edge. But if it ends right there, later on I'll have to make an extrusion sideways that will not cut the tube because it's a circular profile and going outward. What I want to do is I want to move it inside somewhere like this. So it depends. Actually, it's not defined in the technical drawing. We'll just go and make a suitable dimension there, say 15. Okay, we'll take care of this excess line later on. Now what I want to do is I want to close it out and extrude that for 30, and I want to make it symmetric. So we have this, right? We have this, and I'll have to make a cut here. So that saw cut we will do at the very end of the object, so let's not worry about that right now. But I want to get one thing done, is this fillet. I want to get it done because they may create an issue later on. So let's go ahead and make it a fillet right now of 2 millimeter. So we got that taken care of. Now I can take these two and make a connect. So that connect operation takes this excess inside part out. Maybe while I am here, I can go ahead and make this a fillet as well. So take these both parts just to make sure we are covering both bases after saw cut, and take these two. So take all of these edges and make a 2 millimeter fillet. All right, so that part is done. I'm going to go ahead and rename that. So this part won't be changing between phase N and phase 2, so we will just keep it there. Now let's work on the changing part. Maybe at this point I want to save this whole thing. Okay, so this swing arm is at the bottom of this tube looking from the top, and it's 65.5 millimeter long and it has a 15 millimeter width. So I want to build it from this face. So let's go ahead and draw a sketch on XY plane and take simple rectangle, start with there. Right now here what I want to do is I want to make this point not attached to this vertical axis because it will be swinging later, so I don't want to have it attached here. I'll have to come up with some clever situation on that. So let's think about that for a minute. How about we take a construction geometry and draw an arc between these 2 points, right? So this is a construction geometry, and I can place this point on there and maybe place it here. So now it is moving. Now I can say, so this point, right, this point is already touched on this line. I'm gonna go ahead and delete that. Okay. Now I can see these 2 points at the same coincident, and maybe I can make these two tangential. Okay, So although this is tangential, but this point is not actually bound with this line. Now let's take these horizontal and vertical constraints off now. So now you can see this arm is swinging, and that's what we want. But we don't want these to be deformed. So let's make those two perpendicular to each other and these two perpendicular to each other. So what it does is now it will be swinging, but it would it would retain its form. And I want to say this, okay, let's make it deformed like this. So I can go ahead and take this and then make a constraint distance. I don't want to make it a horizontal or vertical distance. I'll be making it like a linear distance, and this one will have the same distance. So this is going to be 65.5. Right. So now it's moving up and down. This is probably a good time to actually make a radius constraint to this, and that is going to be 50 millimeter diameter, so 25 radius. Okay, so now it's there. It's moving up and down. At this moment, I want to see how we can make it horizontal, and one way to do it is to make an angle constraint between these two. So the horizontal line of this and this vertical axis, I can say this angle, there is an angular constraint, say 90 degrees. Okay, so we have this 90 degree, right? We can make that 45, and that will swing up. So this is the phase 2, but in phase 2 this length will change to something else. It will be 73, so we'll have to have a variable on this one as well. So these two variables will be related to phase 1 and phase 2 transition. Okay, now we can see that this part is not solid. We'll take an arc from here. I'll just leave it there for now. What I want to do is I want to make this point coincident on this line, and then this point on this line. Okay, now we may have to come back and fix this, but I'm doing this for a reason. Now I want to make these two equals. Okay, so that's a fully constrained. I do expect to come back and fix this when we see it's not working. Okay, I'm gonna go ahead and rename that sketch as. So this sketch contains two constraints, this 65.5 and these 45, these two constraints that we'll have to come back to change them. So let's go ahead and put some name on there. So this is swing angle, okay, right? And then this is, let's say, arm length. We have these two named, and now they will show up here. Arm length and swing angle. We can say swing angle is 90, and it will come back here. Okay. And now I want to extrude that for a height of, so it would be the total height of the tube, 30, right? So go ahead and make it 30 and make it symmetric. And as you can see, didn't work because the sketch, it's a fully constrained sketch, but there are some issues, and what I expected to have it situations like this. So let's go to Sketcher, and here it says validate sketch. Let's click and say highlight troublesome vertices, and I can see this point has some issue. This point, maybe I want to keep it swinging, so 45, And now let's see if still is the same point. Yes, it's still the same point. And let's go back to it and see what's going on. How about we delete this, like this point and these two constraints. Now they are moving up and down. How about I take all these three and make it coincident to each other, and we have 1 degrees of freedom, which is this line, and I don't see any other way than making it tangential. Okay, so that makes it free, and now I'm gonna go ahead and make these two equal. We still have 1 degrees of freedom left, and which is somehow this point got detached. How about we make them coincident again? Okay, let's see if that solved our issue. Looks like it did. I don't see any points highlighted. So I'm gonna go ahead and go to the part and extrude that for 30 millimeter and symmetric. So that worked. So this is our basic swing arm. Okay, probably bring it back to 90 degree. Okay, so we got that. Now the next step is to make these two holes in there, and I think I'll have to do it in 2 steps. So I will make this bigger hole first, and I want to make it as simple as I can. So what I will do is I will draw a sketch on XZ plane, and then so on phase 2 that hole will also move. So that sketch will also have to revolve or like rotate with this swinging arm. So I'll have to have some way to rotate that plane. How about I create my own datum plane? I'll go to XY and draw my datum plane. Something like this. Let's say these two are equal just to make it simple, and give it a length of say 100. Now we'll make it equal to 25. Okay, and then I'll make these two perpendicular. Okay, so now it's swinging just like this. We can draw something on this line. What I want to do, I want to make this construction geometry. All right, so our sketch will have only this. So this sketch has 1 degree of freedom, which is this angle, right? So we'll have to make that angle 90 degree and 45 degree. So 90, 45. I can take these two and draw an angle constraint. I can say I'll just make it a formula with that previous. So that was a sketch swing arm basic dot constraints dot, was it angle? Yes, swing angle. Right. So now we have 19 there, and when we'll make it 45, we'll probably have it 45. Okay, I think it will be easy. So this is the datum. I'll go back and make this angle 45 for now, so that will actually help me draw things more clearly. Now what I want to do, oh, that took that 45 in the wrong way. Okay, how about I make this sketch swing arm basic, and constraints dot angle, right, plus 90. So the degree symbol, I think it is alter 0176. Yeah, that worked. Okay. Okay, how about this? So now we can go here, I say 90, and that is 90. Notice how this line, this is the sketch. So this line is also moving with the constraint. We say 45, that's moving with that. I think that's, yeah, that's better. All right. So now I can go ahead and extrude this sketch for, say, I don't know, 50, make it symmetric, apply, close, there. So this is our datum plane now. So I'll have to make holes on this, mapped on this face. Okay, start working on it then. On this one, the first sketch is to have a rectangular hole. This one, I want to keep it this size. So, all right, as I said, I'll have to make it 45. It is 45. So here, so this point is actually coming from the sketch right here. So I make this distance, say 10. I want to keep it on that side. And this height will come from the sketch of the technical drawing, which is 14. Right, and how about I make these 2 points symmetric? Right, we're going somewhere. Now only thing left is this length, which is 30. So this length is 30. So I take this point and this point and make this 30. So the reason I wanted to have it at a swing angle 45, because this point I don't want it to be confused with the axis cross, the standard axis cross. So having it at 90 degree, just like this, the phase 1 phase, that distance would conflict with our vertical axis. So I wanted to have it at an angle, so there is no confusion when I'm drawing this line. Okay, I think I can do one better and then draw that circular hole in here and have this distance built in there. But before I do that, I have a thinking. So we'll have to make this slot in the phase 2. So what I want to do, I want to draw a slot right now. Yeah, just like this, right? And make this radius as the radius of the circular hole that I was going to do, and that is 3.3. Okay, we got that 3.3 radius now. And let's take another look at the circular slot. So if you consider this drawing and this drawing, it is obvious that when this circle becomes slot, this part is moving right side. So this left part, if you divide that circle in half, the left part stays in place, the right part moves. So the center will stay in place, and then so this is the point that will move up and down. This point is fixed. I'm going to go ahead and make that determination right now. So that would be 65.5, which is the length of the slot, minus the radius of that area, which is 15. There. So we have this radius that will not change, right? This length 50.5 will not change, but it's coming from the swing arm. So let's find that and say constraints, and then was it length? Yes, arm length 65.5. minus 15 is the height, the radius that I'm about to draw. So all right, so now it is linked with the length. And this point, this side, that's the only degrees of freedom left. That is, this length will become 0 or something else. I don't think it will take it 0, but we can make it like really small. Okay, we will make it, we'll put in a name in there. I'm gonna say slot length. Okay, we'll have to remember that name. Okay, let's see so far if it worked. It's slot holes. So if it works on this sketch, we'll have to change one value. When we go to phase 2, that would be the slot length. I want to extrude that for say 20 millimeter, and maybe on the other side, other way, right? Yeah, just like this. And see, so this is the datum plane. Now it is important to name everything because we'll have to come back and forth a lot of times. This is arm holes, and I want to make a deduction, and let's hide this. So it worked, right? And now I can say the placement, actually find that here I'd say 5 millimeter, so that slot is changing. 7 millimeter is coming this way, which is good. We can go find the other sketch and say arm length is 75, good. This angle is 45, good. So everything's moving along great, and it is always good to have these checks every now and then during the model building, just to make sure we are not getting derailed. Okay, I want to make this constraint really small value, just to make sure it looks like a, yeah, it looks like a circle. I mean, if you didn't see me doing this as a slot, you'd probably never know that it's a slot, not a circle, but it does look like a circle. So that plan is working. Now we have another thing to do, is to have these two edges filleted to 15, let's say 14.99, and maybe I can make it a cut instead of a fillet. I'm really hesitant to place a fillet in the middle of the object, although I did it in the first phase. Let's see if I can make a cut right here. Okay, so this would be a 15 millimeter. Okay, so these two will be on the same vertical plane, right? And then the radius will be 15. Okay, and we'll have to close it on the other side, just like this, and maybe have this length something bigger than 15, maybe 20. Okay, let's see. Yeah, that worked beautifully. I mean, now I didn't have to create the fillet, and there is no line in the middle with that 0.01 millimeter of inaccuracy. Okay, now we are almost there. All I have to do is have this countersink in there, and now that I'm seeing there is another countersink on that side too, so our work on this part is not finished yet, so we'll have to get back there. But before we do that, since we are on the swing arm, let's create another sketch on this datum plane. On here, let's create another sketch, and then I would like to have this center point. Okay, so this is the whole sketch. Let's make it some millimeter, say 5 millimeter. Okay, that's nanometer, make it M. Okay, and now let's go back to the new sketch, because I want this center point, not this one, if it makes sense. So I want to have that sketch visible as well, and maybe hide this datum plane. So now I can go ahead and take reference of this. So that gives me this point. Okay. On this one, I want to build a slot. Another slot, just like this. And this will obviously be bigger. And this radius comes from the technical drawing, which is, it says diameter 11. So this radius would be 5.5. Okay. Now this slot length will be the slot length from the previous sketch. So let's take this and make a dimension of, say, sketch find that's doing, so slot holes, yes, and constraints, and then I'm say slot length. So that would be the same. And we have this, so rename that as sketch countersink. On this one, I want to push it down for, I think it calls for 6 millimeters, and we will want to make it reversed. Okay. What it does is, I'm going to hide this and bring it back. What it does, it pushes it down. Now I can go ahead, make another cut. So this is counter sink, and I can make a cut, another cut, and now that's a countersunk hole. Okay, so this is the swing arm. I want to go see if this is working. On here, I want to make this 90 degree, comes back, and on the armholes, we want to say the slot length, we won't go less than 10 micrometer. I want to say if I can make it 10 millimeter. That's working. Okay, so let's not go less than 0.01 millimeter. Okay, so now I have swing arm, I have this part. All I have to do is put them together, but before I do that, there is one thing that I need to do, is to have this countersunk, and I'll probably do it using cylinders. So I want to take this cylinder and transform it this way. Okay, move it probably at the center. Okay, now let's take a look at that part. So this is the total length, it would be 30, and 6 on either side will be countersunk. So this length is going to be, this height is going to be 30 minus 6 minus 6. Okay, so that's 18, right? On the position on Y, I want to say this should be half of the height. The height, that would be a formula actually. Height divided by 2. And Z, let's make it 0. Okay, so there. Now I want to move it to match with this. So let's move it manually at some ballpark number. And there. Now that will give us an idea like how far it is moving. It will actually move 32.5. Actually no, 30 is the one that we were looking at. So that is exactly at the center, right? Now I want to draw two sketches on these two faces. Now previously I mentioned the topological naming issue, and then we should not do that, but the new 0.22 version, like when the FreeCAD 1 version comes up, I know for a fact that that issue is not going to prevail. And let's go ahead and do what I told specifically not to do, is map sketch on one of the surfaces. On this side I want to draw a circle big enough to match with the countersink, which is radius 5.5. okay, we got that. And on that I want to extrude that for 6 millimeter towards me. Okay, got that. On this face we will do the same, and I will do, okay, it looks weird, so let's turn on the section view. Still looks weird, but all I want to do is draw a hexagon here, and this profile looks like, yes, so that's what it looks like. The distance is given between these 2 points. The distance is given as 11. Okay, cool, we got that. On this I'll draw it out for another 6 millimeter. And now I want to take these three and put this together as a union and say this is the bolt profile, or like bolt cutout, and I want to cut it out from here. So maybe should have not renamed it just yet, but let's make it a cut and say this is the holder part, right? That's the holder part with some fillets going in there, and here we have this. Can we make it some fillets preemptively in there? I know that this joint will have some, so how about here? How about I make a couple fillets on this? Can we make that? Yes, we can make that. And maybe now I can go ahead and make these two as well. Okay, when I did that on within this one, I want to include these two lines as well. Okay, now I want to do this one and this one. All right, so these two parts will merge, and that's why I don't want to touch them right now. But so far so good, it's working fine. So this is the arm with fillets, and that's the holder with fillets. Now let's go ahead and put these two together, and that looks beautiful. So we have final model. Well, not final yet. I want to do couple fillets on here. Maybe first of all I want to do it from this side. I want to take this and this. I want to take these two and make 2 millimeters fillet, and that did not agree with me. That says nope, I'm not going to do that. Probably because this carved profile is coming up all the way, and then these three lines are coming in one point and creating some issue. We may have to call it a model without that fillet. Okay, how about these two? Can we make these two fillets? Nope. And again, that is because we don't have enough room in here. We can probably take it a tiny fillet of 0.2 millimeter. Yes. So that will do, but as soon as it encroaches upon here, that looks, yeah, so that explains. Well, other than the fillets, I mean, the object looks great. So this is the final model, and so I want to make this video end here, and I say in the next video I will show how I can make this phase 1 and phase 2 go from one model to another within one click via a parametric configuration table. So now we'll have to go find all these sketches and actually see. So find this and then change this constraint. I want to make that transition simple with a spreadsheet and configuration table. So we will do that in part 2 of this video. This video is already really long, so I want to do that in tomorrow's video. Please take a look at it, and if you have any other question, comment, or suggestion on this model, please let them know in the comment section below, especially how you would handle this transition between circle and slot, these points like in interchanging with each other. Let me know how you handle that. Thank you for watching. See you tomorrow then.